Welcome back to Graphing Quadratic Functions, section 4.3. We are going to start by changing a quadratic from standard form into vertex form and then graphing it by using transformations. So the way we do that is we complete the square in x and then we graph. So to complete the square, remember we take the b term. So if we look in front, remember we have a, b, c. Those are our coefficients. So to complete the square, we have to take half the b term and square it. Now, if you recall before when we had equations, we had to add that number to both sides of the equation. When we're completing the square in a function, it's slightly different. What we're going to do is do what mathematicians call add a well-chosen zero. And the way we do that is by adding and subtracting the same number. So to turn this into vertex form, we are going to take the x squared plus 4x, and then we're going to leave ourselves a blank. The minus 1 is outside, and since we put plus a blank inside the parentheses, we're going to put minus a blank outside. We are going to add and subtract the same number from this side of the equation, and that's the same as adding 0, because we added it and then we subtracted it. So what is that number we add? Well, this is where we complete the square. We take b and divide it by 2 and square it. So our b is 4. Divide that by 2 and square it. We get 2 squared, which is 4. So we're going to add 4 inside the parentheses and subtract 4 outside the parentheses. Now we're going to factor. And so x squared plus 4x plus 4 factors into x plus 2 times x plus 2. And then we'll combine the negative 1 minus 4 that's outside. And the last thing we do to get it in perfect vertex form is instead of writing x plus 2 times x plus 2, we write x plus 2 quantity squared. Now from here, we can figure out how to graph it. Because our normal x squared I can put the points in the right place anyway, looks like this. So what kind of transformations do we have here? If we look, we have a horizontal shift left 2, and we have a vertical shift down 5. So every point we move 2 left and down 5. So 2 left, down 5, 2 left, down 5, 2 left, down 5, and then we can use symmetry. So the blue line is our x squared plus 4x minus 1. So in some ways, the completing the square part's a little bit harder, but that's okay because we make up for it on graphing by transforming. Now, how do we find the vertex and the axis of symmetry without ever graphing? Well, that's easy enough. We take our equation, complete the square, and decide whether it opens up or down, and then figure out the vertex and the axis of symmetry after we get it in vertex form. So let's look at negative 3x squared plus 6x plus 1. This is a little bit problematic because to complete the square, a must be 1. What do we have here though? We have an a of negative 3. So when we complete the square, it's going to be a little bit tricky. So first, we're going to take the negative 3 out just of the x squared and the 6x. Because remember that plus 1 we don't include in the parentheses. Then we're going to add a number and we're going to subtract a number. In the previous problem, that number is the same. This time it will not be, and I will explain why in just a minute. First of all, though, let's complete the square. So we have b over 2 squared is negative 2 over 2 squared, which is negative 1 squared, or 1. So we're going to put a 1 there, inside the parentheses. Now, what is the problem here? Did we really just add 1? The answer is actually no. We actually added a negative 3 because when we distribute that negative 3 back through this parentheses, we have to multiply the negative 3 times the 1. So that means where we're subtracting on the outside in our second blank, we are actually subtracting a negative 3. So now, if we clean that up, the negative 3 stays out front. X squared minus 2x plus 1 factors as x minus 1 times x minus 1, so x minus 1 squared. And then negative 1 minus a negative 3 gives us plus 4. So remember, this lines up as a times x minus h squared plus k. So the vertex, remember, is the point HK. So our formula says x minus h, so we have x minus, h is 1, and then plus k, so k is 4. The axis of symmetry is always x equals the x coordinate of the vertex, so that's 1. And then, does the parabola open up or down? It opens down because A is negative. So that's how we graph these using the completing the square and graph using transformations method, and how we can identify information about the function, like its vertex and its axis of symmetry that way. In the next video, we'll talk about the second method.